Every mystery has a starting point. Ours has three. A visitor called 3-Eye Atlas traces back toward the Archer in the crowded heart of the Milky Way. A single narrowband radio burst once rang from that same direction at the hydrogen line, and for a century, Earth has been leaking radio and radar into that very sky. Could this all be a lucky overlap, or are we staring at a pattern with our name on it? Here is the paradox. If it is chance, it is staggering. If it is choreography, we have already been answered. Tap subscribe, stay with us, and let us test this together. Begin with the sky you can stand under tonight. Sagittarius the Archer is not just a shape made from stars. It is a sightline toward the galactic bulge, where stellar crowds are denser, histories are longer, and the odds of planets and civilizations multiply. When astronomers trace a path backward through deep time and that path points into the Archer, they pay attention. Direction is not proof, but it is not nothing. A compass heading is the first clue in every investigation. Now consider the burst that refuses to fade. In the late 1970s, a radio telescope in Ohio logged a narrow signal at the hydrogen line. That is 1.42 gigahertz, a natural frequency any species that studies physics will notice sooner or later. The event lasted about 72 seconds and did not repeat. It was strong, crisp, and alone. Many natural explanations have been offered, yet none has closed the case. The cleanest reading is not a paragraph in a message, but a bright ping placed where beginners look first. Add the third thread, our own voice. For roughly 100 years, Earth has been broadcasting. Weak radio shows, stronger television carriers, and the bright pulses of military radar have poured outward at the speed of light. Picture a growing sphere, roughly 200 light-years in radius. Thousands of stars now sit inside that bubble. Some are in the Archer direction. If anyone there has ears, they have known we exist for decades. Round-trip timing turns romance into geometry. We speak, they hear, they answer. We hear much later. So why call it a triple convergence? Because each piece alone is ordinary enough to argue away. A visitor from somewhere, a lonely radio spike, a century of our own leakage. Together, the three stack into a shape our brains are built to notice. Path toward the Archer, ping from the Archer, human noise already bathing the Archer. Coincidence is still possible and we will give it a fair fight, but the overlap is precise enough to demand a harder look. Here is how we will run that look. First, we will translate the sky map into plain language. Sagittarius is not magic. It is a crowded district of the galaxy, with more everything, more stars, more planets, more laboratories for life. If you wanted to be noticed by young species, you would aim from a place like that. You would also use signposts the universe provides. Hydrogen sings at 1.42 gigahertz. That is why search strategies anchor there. It is the radio version of meeting at the town square. Second, we will be strict about evidence. A direction is a hint, not a signature. A one-time signal is a flag, not a handshake. And an interstellar path needs more than poetry to claim design. We will keep the skeptical lens polished. We will ask what detection biases might point our attention toward the Archer, even if the universe is random. We will check whether our own surveys favor that region and whether our expectations color what we think we see. Third, we will own the stakes. Interstellar visitors pass once. If you blink, they are gone forever. If 3-Eye Atlas is simply ancient debris, we still learn. If it is something else, a messenger disguised as stone and ice, then the gaze staring back at us is not theoretical. Either way, this is not a story to watch from the couch. It is a story to test. That is the point of staying, subscribed, and coming back as new data drops. The paradox remains, and it is worth repeating. If this is chance, it is a golden lesson in humility and statistics. If this is choreography, it is the softest and smartest hello imaginable. A direction we could verify, a ping we could not ignore, a visitor we could study without panic. That is how you introduce yourself to a species still learning to speak beyond its own sky. Before we leave this opening, commit one small map to memory. The Archer is not an omen, it is a lane. Our radio bubble has reached that lane. A clean radio ping once came from it. A rare object now points back into it. 3 threads tied to one knot. We will spend the next chapters pulling gently on that knot and seeing whether it loosens into coincidence or tightens into a pattern. Keep your curiosity close and your doubts closer. Both will be needed. Start with a star map you can hold in your head. The Archer is a teapot of bright stars low on the southern sky for many observers, steam seeming to rise along the band of the Milky Way. That pretty picture hides the real punchline. When you look into Sagittarius, you're staring down the crowded avenue of our galaxy. The star fields thicken, dust lanes turn the sky into velvet smoke. Far beyond the foreground constellations lies the galactic bulge, and the massive object at the center that holds the spiral together. Direction here is not folklore. It is a physical tunnel of probability and history. Constellations are human connect the dots. The physics behind them is not. 88 official constellations parcel the sky for convenience, but only a few sit along the great river of starlight we call the galactic plane. Sagittarius does. That matters for traffic. More stars mean more planetary systems. More systems mean more chances for chemistry to try and try again until something that thinks appears and begins to use energy in obvious ways. If you wanted to place a mile marker, where, with young astronomers would eventually look, you would pin it along this river, not in the quiet outskirts. Now shrink the scale and think of a single line of sight. We do not see depth very well from Earth. We see directions. A trajectory that points back into the Archer is a pointer into a dense district, not a single house on a single street. That is why you will hear us say direction, not address. A path into the Archer says, look here, then demands the next question. Here where? Which star? Which cluster? Which old encounter? The forensic game begins with a compass heading, then tries to stack three-dimensional motion on top of it. There is a practical reason the Archer repeats in this story. Our instruments love this sightline. Radio telescopes map the central regions because bright hydrogen, carbon monoxide, and other traces outline the anatomy of the galaxy. Infrared observatories look this way because long wavelengths slip through dust and reveal stars hidden from ordinary light. Even backyard astronomers favor this region because globular clusters and nebulae crowd the field. That focus creates an observational bias we will keep admitting. We look here a lot, so we find things here a lot. But a bias does not invent a hyperbolic visitor. It only increases the chance we notice one. Zoom out again and add basic geometry. The Milky Way is a wide disk with a swelling core. Picture a dinner plate with a grapefruit in the middle. Looking along the plate, especially toward the grapefruit, gives you the longest possible hallway of stars. If spacefaring machines or natural fragments drift in large numbers along that hallway, then random interceptions with our own orbit happen more often from those lanes than from empty sky off the disk. That is not mysticism. That is statistics shaped by structure. There is also the patience factor. Civilizations that plan across millennia do not shout in all directions. They use landmarks. Hydrogen's natural whisper. At one point, 2 gigahertz is one. The galactic center is another. If you want a newcomer to catch on without panic, you point them to the town square they were already beginning to study. You choose a direction that is already on their homework list. When they look, the breadcrumb is there, not a confession, a nudge. So what makes the Archer a hub, rather than just a busy neighborhood? Age. Metal-rich stars have been forming here for eons. Old giants and newborn clusters live side by side. That mix means long technological head starts could have been possible closer to the center, while fresh laboratories keep appearing farther out along the arms. If infrastructure ever accumulates in a galaxy, it will accumulate where many stories overlap across deep time. Ports form where routes naturally cross. In maritime history, that is obvious. In galactic history, it should be too. We also need to be blunt about the counterpoint. Sagittarius covers a large patch of sky. If you throw enough arrows, one will land there. That is why chance must always be on the table. The responsible question is not could it line up, but how much does this alignment raise the odds that something non-random is going on when combined with the other threads? Direction alone does not carry the day. Direction plus timing plus chemistry begins to look like a case. Before we leave the map, lodge 2 coordinates in memory. First, the Archer marks a line toward the densest region of our home galaxy. Second, many of our most powerful instruments already stare along that line, which means new data arrives from there faster than most directions. That is why a visitor whose path rewinds into Sagittarius commands attention. The lane is crowded. Our ears are already pointed that way. If a story were trying to be found by cautious investigators without breaking anyone's worldview, this is where and how it would choose to be seen. Picture 3 kinds of paths around the Sunday. First, the cozy ellipses of planets, and most comets, like racetracks that loop forever. Second, stretched ovals that still fall back eventually. Third, the escape path that never returns. That last one is the key. When astronomers plot a new object over several nights and the math says it is on an open curve, not a loop, you are not looking at a local. You are watching a traveller from somewhere else, on a one-time pass through our yard. How do they know so fast? They take careful snapshots against background stars, then measure tiny nightly shifts. From those shifts, they calculate speed and direction. If that speed is above the sun's grip at that distance, gravity cannot reel it in. Think of throwing a ball. Toss it gently, and it arcs back. Throw it hard enough, and it keeps going. Space does the same thing, just with numbers that make your head ring. Once a path is confirmed as open, the clock starts ticking. We will not get a second chance. Here is where the urgency comes from. Interstellar visitors brighten only for a short window as sunlight warms them. Then they fade and vanish into the dark. A few weeks late on the best observations can mean losing the only clean spectra, the only crisp shape measurements, the only chance to catch odd behavior that might rewrite a textbook. Even big observatories cannot always pivot in time. Schedules are crowded. Weather refuses to cooperate. The universe does not care about our calendars. We have very few of these in the record. In 2017, Oumuamua slid through with a shape and motion that defied easy labels. In 2019, Borisov arrived looking delightfully comet-like, a reminder that many things out there behave just like the things in here. Then came 3I Atlas with its own quirks and questions. 3 cases are not a census. They are a tease. That scarcity is why each anomaly matters. When you only hold a handful of puzzle pieces, the picture each piece suggests looms large. So what does gravity allow and forbid? It allows gentle deflections from planets. It allows sunlight to push on gas and dust, nudging the path of objects that vent material as they warm. It forbids magic turns that come from nowhere. If an object changes course in a way that natural forces cannot account for, the mystery becomes sharp. Most of the time, the simple answer wins. Jets of gas can act like tiny thrusters. Subtle measurement errors can masquerade as weirdness, but every time numbers refuse to line up, you feel the edges of our model flex. You might wonder why one pass only keeps returning in this story. Because it sets the tone. Local comets return again and again. We can plan perfect campaigns and catch them at leisure. Interstellar visitors honor no schedule. They do not care about our night side or our moon cycle or whether the biggest telescope is busy. They come when they come. If a detail hints at something surprising, we must move with it now or not at all. This is where citizen scientists help. Amateurs with modern cameras can log thousands of images while the big guns wrestle with logistics. Crowdsourced timing and brightness measurements can expose outbursts, flickers, and subtle spin rates. That ground truth can steer professional time toward the right nights and wavelengths. When you have a once-only guest, you accept every pair of eyes you can recruit, and you build a timeline dense enough to catch the moment the guest does something interesting. We also need to be honest about how few nights define everything we say later. A dozen data points can anchor a year of debate. That is why reprocessing old images matters. Hidden in the noise of a wide-field survey, there might be an earlier detection that sharpens the path and tightens the story. Archives are the time machine in modern astronomy. We go back, pull more signal from the grain, and sometimes watch the uncertainty shrink until a mystery turns into a measurement. So, what have we learned so far? Interstellar status is a property of the path. Open curve, not a loop. The label does not make an object alien, only foreign. The stakes come from scarcity and speed. You get a brief, bright chapter to read and then the book is gone. And the payoff can be huge. Even a perfectly ordinary interstellar visitor teaches us about how other systems build comets and rocks. An odd one pressures the models and dares us to imagine what we have not yet measured. Hold that frame as the investigation deepens. 3I Atlas is interesting because its path says one pass only, and its details keep asking for follow-up. If it is a natural traveller, we still win, because nature just widened our sample. If it is something else, the case for that will only emerge through disciplined measurements, not wishes. Either way, the clock is still ticking. When the lights dim on a visitor like this, they do not come back up. Begin with the sound you cannot hear. In mid-August 1977, a radio telescope near Columbus let the sky drift through its fixed gaze, and something narrow and bright rang out at the hydrogen line. The printout spiked. A volunteer circled it and wrote one excited word in the margin. The name stuck. The data did not budge. A slender tone at 1.42 GHz, about 72 seconds long, strong against the noise, then gone. No fade in, no fade out. A door opened, then shut. Why does that specific frequency matter? Hydrogen is the most common element in the universe. Its natural radio whisper sits at 1.42 GHz. Any species that builds radios and studies physics will discover it early. That makes the hydrogen line a universal town square. If you wanted to place a beacon where beginners look first, you would put it there. Our earliest search strategies did exactly that. We spent years listening near that frequency, hoping for something unmistakably artificial and unmistakably simple. The WOW signal fit both hopes and both constraints. It was not broadband like lightning or noisy electronics. It was a clean, narrow tone that rose and fell with exactly the timing you would expect from Earth's rotation. The telescope did not track targets. The sky slid overhead. A real source would flare in the beam for roughly a minute and change as the planet turned. That is what the record shows. The shape matched the instrument. The strength rose, peaked, and fell like a lighthouse passing your eye. Then came the problem that still bothers careful minds. It never repeated. The team went back. Others went back. More telescopes listened at the same patch of sky and heard the ordinary hiss of the universe. Natural suspects took turns under the lamp, a passing satellite, a badly shielded transmitter on Earth. A quirk of the instrument. Each explanation had to answer the same puzzle. Why would a mundane source appear once with textbook drift timing at a frequency chosen by physics class and then vanish forever? None of the easy answers locked in. There is another natural lane worth naming. Space is full of mazes, clouds that amplify radio waves at specific frequencies. But the profile and strength of this event did not sit comfortably with known clouds along that line of sight. Pulsars did not fit, solar outbursts did not fit, the list grew, and the mystery did not shrink. In science, a single anomaly rarely wins. You want repetition, localization, a trend you can pin to a coordinate and return to, at will. Here, we have a one-time tone, a smeared address, and a legend built on restraint. So, what if this was not a message in the way we imagine messages? No alphabet, no coded page, just a ping placed exactly at the universal signpost. One clear knock on the door to prove a point. We see you. We know the square where you gather. We can reach you. Then silence to see who noticed. That idea is simple enough to be tempting and humble enough to be plausible. A civilization cautious about giving away home addresses would avoid long broadcasts. A single ping contains no location. It only reveals the receiver's vigilance. We should also be honest about the telescope itself. The instrument used two adjacent beams. That created two possible sky tracks for the event. The signal appeared in one and not the other, which is consistent with a real source that drifted through only one beam. It also leaves ambiguity about the exact spot among stars. That is why searchers that followed could aim and still miss. The window was narrow, the address was broad. Time marched on. Here is where the archer walks back into the room. The best fit positions fall in the general direction of Sagittarius. That is not a street name. It is a compass, bearing into the crowded heart of the galaxy, where our instruments already spend time. Combine that with the hydrogen line choice, and you get intent without content, the radio equivalent of a raised hand during roll call. Present, watching, your move. Could this have been Earth's own noise sneaking into the feed? Engineers have beaten on that worry for decades. Procedures existed to exclude local interference. The telescope's design and the drift profile match a source beyond our atmosphere. Is it proof? No. Is it the cleanest candidate in half a century? Many would still say yes, precisely because it refuses to collapse into an easy natural category, and because it sits at the one frequency every freshman physics class learns to whisper. So where does that leave us? With a tone that behaved like a real source, at a frequency that begs to be used for first contacts, in a direction dense with targets, recorded once and never again. If the goal was to be noticed by a young species without shouting, mission accomplished. If it was a natural oddity, then nature wrote a convincing impersonation of a calling card. Either way, the lesson is the same. You do not get to choose the form of the first knock. You only get to decide whether to open the door. Imagine a sphere growing outward from Earth at the speed of light. Every song broadcast, every news anchor's voice, every airport radar sweep pushes that shell a little farther. The earliest transmissions from the early 20th century now sit well beyond 100 light-years from home. Newer and much stronger signals ride behind them like waves on a lake after a ship passes. It is not a perfect sphere. Some emissions are narrow beams, some are broad and leaky, but together they trace a glowing frontier, announcing that a technological species woke up here. Not all signals are equal. Early radio shows were faint and easy to drown in cosmic static. Television carrier waves are brighter. High-power radar, used for tracking aircraft and mapping asteroids, is brighter still, with brief pulses that can outshine a star at specific frequencies for an instant. Add deep space communication links to interplanetary probes, and you get yet another set of beams stabbing outward. If you are listening from a nearby star, you do not hear our entire culture. You hear an uneven chorus, loud in some directions and whisper soft in others. Picture that frontier overlapping with real neighborhoods of stars. Within 100 light-years sit thousands of suns, many with planets, some along the same broad direction as the Archer. Our oldest broadcasts reached them decades ago. The mid-century television era is arriving at stars farther out right now. Modern radar is only beginning to light up the closest shell. Round-trip timing turns into simple stories. A star at 50 light-years could have received our 1970s chatter by the 1970s there, sent a reply, and had it reach us around the time some of us watched the first personal computers come alive. There is humility in this geometry. We are not broadcasting to the whole galaxy. The Milky Way is 100,000 light-years across. Our loudest shell barely covers a local bubble by comparison. Yet that small bubble is already a forest of chances, thousands of targets, millions of nights, plenty of opportunities for someone to notice the odd glint of an artificial carrier and say the simplest word any civilization can manage across distance. Present. The bubble is messy in useful ways. We did not coordinate a beacon. We built a civilization, and the beacon fell out automatically. That means the signal is redundant. Shut down one transmitter, and another takes its place. Even attempts at silence fail in practice because useful systems are noisy by nature. Navigation satellites chirp, weather satellites whisper. Scientific radar pings. The noise floor of a technological world rises, and over decades the signature becomes unmistakable to ears as sensitive as our own. Of course, detection is not decoding. A listener would not reconstruct sitcoms from the 1950s unless they parked a truly giant dish very close. What they could do is see the shape of our spectrum and the regularity of our modulation. Artificial carriers reveal themselves by their order. Nature loves noise and broad bands. Technology loves narrow lines and rhythms tied to clocks and standards. Even without understanding our languages, a distant analyst could say with confidence that a planet in this system has learned to engineer its environment. So where does the Archer come back into the picture? As our bubble expands, it fills that sightline just as it fills all others. But the psychology of search matters. We aim more telescopes towards Sagittarius because it is rich with targets. Others might do the same. If you were stationed anywhere along that direction and scanning the sky for newcomers, you would want your watchers to hear the clearest version of our noise. That suggests a patient strategy. Let them hear us first, then give them a single unmistakable knock at the hydrogen line. Then, long after, send something they can study with cameras instead of antennas. There have been deliberate attempts to say hello as well. In the 1970s, humans beamed a tightly crafted message toward a distant cluster to prove we could. In later decades, we repeated the gesture toward nearby stars with simpler signals. These are pebbles tossed into the same pond. They ride the leading edges of our noisy bubble but do not define it. The accidental chorus is the true announcement. Here is the uncomfortable implication. If anyone inside that radius chose to answer as soon as they confirmed we were here, we might already have received their reply and not recognized it for what it was. A one-time ping fits the bill. A physical visitor that looks natural at first glance fits it too. That is why the bubble matters to this story. It supplies the timing and the motive. We built a lighthouse without meaning to. Someone saw the beam. If they chose to remain cautious, they would respond in ways that reward patience rather than panic. So keep that growing sphere in mind as we weigh each clue. Our neighborhood is not quiet anymore. The proof of us rushes outward every second, whether we speak on purpose or not. Out there, the line between coincidence and choreography narrows to the size of a plan. We may already be reading the first pages of that plan without realizing it. Imagine you are a detective, with only a handful of photographs taken minutes apart as a suspect walks across a crowded square. That is how orbital reconstruction begins. Astronomers measure where an object sits against background stars on night 1, night 2, night 3. From those tiny shifts, they solve for a three-dimensional path and a speed. Once a preliminary orbit exists, the math rolls time backward step by careful step, letting gravity do what gravity always does. The sun pulls, planets tug, nearby stars nudge. Even the broad tidal field of the Milky Way contributes a slow pressure that bends paths over millions of years. This rewind is not a single curve traced with a pen. It is a cloud of possibilities. Observers feed the best fit and the uncertainties into a numerical engine and generate many slightly different clones of the same object. Each clone begins within the error bars of the measurements, then runs backward under the same physics. If the object once passed near a plausible parent star, many clones should converge on that encounter. If nothing lines up, the cloud smears until it is only a direction, not a birthplace. The tools behind this are precise and patient. Star positions and motions come from space-based catalogues that map distances and velocities for vast numbers of suns. Planetary ephemerides give the locations of the major bodies in our system with exquisite accuracy. Integrators march the equations forward or backward in steps so small that round-off errors stay caged. Yet every rewind fights two enemies. The first is chaos. Small uncertainties grow with time like ripples spreading from a stone. The second is ignorance. We do not know every tiny mass that matters along the way, so the model must average what it cannot resolve. There are natural ways for a path to blur beyond recovery. A glancing push from a star long ago that no catalogue contains, an ancient brushing of a molecular cloud, countless feather-light tugs that add up over deep time. When the object is very old, these nudges can erase any clean link between here and a specific there. In that case, the rewind points toward a district rather than a door. Sagittarius becomes a bearing, not an address. There are also non-gravitational forces to test. Comets vent gas and dust when warmed by sunlight. Those jets act like thrusters so small you would never feel them, yet over months they shift the path enough to matter. Analysts fit for these subtle pushes by looking for steady drifts that gravity alone cannot explain. If the data support it, the model includes a gentle extra term that leans the trajectory. If not, the clean gravitational picture remains. So what did the investigators see when they ran 3I Atlas backward? They found a path that looks interstellar beyond doubt, an open curve on which the sun never closes its hand. They found encounters with stars that were interesting but not convincing, either too distant to bind the object long ago, or requiring escape speeds that do not make sense. They found that the farther back they pushed, the faster the clone cloud widened, until the only statement that remained honest was a direction into the archer, rather than a specific source. At this wall, the interpretation splits. One reading says, "Great age. The traveller has wandered so long that time itself has shredded the breadcrumb trail." The other reading says, "Careful design. If you wanted a messenger to seem natural at a glance, but also to avoid betraying its origin, you would set a path that remains plausible under gravity, yet refuses to tie itself to any homestar when rewound." The signature of purpose would be absence, not a neon arrow. Skeptics answer with a reminder that absence can simply be what old looks like. They are right to say that a lost parent is not an exotic claim. They are also right to demand a higher bar before invoking engineering. That is why orbital forensics is only one pillar in this case. It tells us where to look and how hard to look, but it does not pronounce judgment by itself. Still, there are practical moves to make. You reprocess archival sky surveys to catch pre-discovery images that tighten the early path. You coordinate radar and optical timing when possible to shrink the cloud now, because a better present orbit makes a better past. You scour the star catalogues for new motions as they are released, because a revised velocity for a nearby star can change whether a flyby once made sense. Each update can turn a smear back into a thread, or confirm that the smear is all there is. Hold one image as we move on. A room filled with simulated trajectories arcing backward like ghostly ribbons, most diverging, none quite settling on. A clear origin. At the center of those ribbons sits the simple fact that started this whole inquiry: a line into the archer. For a natural interpretation, that line is a reminder that crowded directions make crowded stories. For a designed interpretation, it is the neatest possible hint a cautious sender could have chosen. In both readings, the method stays the same. Measure, rewind, test. Admit what you cannot know yet, and keep going. Two clean stories walk onto the same stage. The first says nature did this through age and accident. The second says someone did this through patience and design. Both wear the same costume, a hyperbolic path, a direction into the archer, a trail that smears when you rewind too far. If the signatures look the same, how do we tell the players apart? By asking what each story must assume, what each story can explain without strain, and what would force one of them to blink. Start with the ancient and natural reading. Space is full of debris that takes the long road. Stars form, fling ice and rock, and gravity serves as a blind croupier shuffling fragments into interstellar space. A traveler wanders for millions of years, tugged by feathery forces that leave no clean trace. When it finally brushes our sun, we measure an open curve and a bearing toward a crowded district, because crowded districts overlap many possible pasts. In this reading, mystery comes from missing information rather than from intention. Now, the engineered trajectory. Imagine a civilization that thinks in geological time. If it wanted to visit without starting a panic, it would choose a plan that survives long after launch. Launch once, aim carefully, let physics do the rest. You would pick a bearing that young astronomers already study. You would not make the object shout with obvious behavior. You would reward patient observers with small puzzles that feel natural until enough of them stack into a pattern. You would leave just enough doubt to keep the reckless at bay, while inviting the curious to lean closer. Each story carries obligations. The natural story must explain why composition and behavior fall inside the broad, messy spectrum of what the universe already does. That means unusual chemistry is allowed, as long as it is not impossible. It means compact activity near the surface is fine, as long as sunlight can drive it. It means a lost origin is expected for an object that has roamed too long. The engineered story must explain why ambiguity never tips into spectacle. That means no obvious propulsion, no blinking beacons, no easy coordinates. It means just enough strangeness to be seen by the prepared and missed by the unready. Evidence can cut both ways. A compact coma is a rare style of outgassing for a comet, and also a tidy way to disguise regulated activity. An unusual balance of carbon dioxide and water is a hint that the object formed far from a warm star, and also a hint that a shell was tailored from exotic ices. A path that refuses to point to any home star is the hallmark of deep time and also the hallmark of a route selected to erase its footprints. When one clue serves two masters, the only honest move is to widen the test set and watch for a tell that one model cannot mimic. So what would count as a tell? For the natural story, a clear non-gravitational acceleration that tracks with heating and vents. For the engineered story, a maneuver that cannot be tied to sunlight or gas, a response to a time transmission, a periodic modulation buried in a tail, a repeatable signature that says this is not geology. Until such a tell appears, we live in the realm of priors and patience. Scientists will weight the natural first because it has won so many times before. That bias is not cynicism. It is a hard-earned survival skill. There is a social trap to avoid. It is easy for camps to form and dig trenches. In one trench, every anomaly becomes proof of intention. In the other, every coincidence becomes proof of boredom. Neither state of mind helps. The honest position is mobile. You adjust as new data lands. You admit when a favorite idea loses ground. You celebrate disproof because it sharpens the next question. A shared investigation only survives if both sides keep the ladder to the middle of the field open. There is also a practical reason to carry both hypotheses forward at once. They generate different predictions and different observing plans. The natural plan watches heating curves, hunts jets, and models tiny drifts in position. The engineered plan tries timed hails, crowdsources light curves to catch odd periodicity, and combs archival spectra for narrow features that do not belong. If we only chase one path, we cut our discovery odds in half. If we chase both, either answer makes us better at reading the sky. Notice what neither story demands. Neither requires new physics. The natural story leans on gravity and sunlight. The engineered story leans on planning and camouflage. It does not need faster than light travel. It only needs patience long enough to make human history feel like a blink. That patience is what makes the second story feel eerie. It suggests someone might have aimed at us before our species built cities. That is a heavy thought, and heavy thoughts deserve evidence before we adopt them. Here is the working truce as we continue. Default to natural. Do not ignore patterns. Keep a running list of possible tells and design tests that are cheap to repeat and hard to fool. Publish methods in daylight so that independent teams can try to break them. Welcome results that reduce drama without reducing wonder, because a natural traveler from another star is still a miracle of statistics and a gift to science. If a different kind of traveler is hiding in plain sight, quiet rigor will be the way we find it, not shouting. Hold both stories in your head without letting either harden. Curiosity rides between them like a bridge. As new clues arrive, the balance will tilt. If it tilts toward age, we learn how the galaxy seeds its wanderers. If it tilts toward design, we learn that someone out there plays a very long game. Either way, the road ahead is the same. Measure carefully, think loudly, speak cautiously, and refuse to let hope or skepticism do your seeing for you. Start with light broken into colors. That is all spectroscopy really is. You take the glow from the thin gas around a visitor and spread it into a barcode of bright and dark lines. Each line belongs to a molecule. Water leaves one kind of fingerprint. Carbon dioxide leaves another. Compare the brightness of those lines, and you can tell which ingredients dominate the coma, the thin atmosphere that boils off the surface as sunlight warms it. For comets born in our own cold yard, water usually runs the show. Carbon monoxide and carbon dioxide are present, sometimes strongly, but water tends to be the star near the distance where sunlight wakes them up. 3i Atlas refused to play that familiar tune. The balance leaned the other way. Observers reported a surprising abundance of carbon dioxide compared with water, a profile that is not unheard of in the universe, but is rare enough to make you sit forward in your chair. There are natural ways to build an ice with more carbon dioxide than water. If a comet forms far from a warm star, deep in the freezer of its home disk, carbon dioxide can freeze in large amounts while water is less abundant. If that nucleus spent most of its life at brutal cold, it could preserve that mix for ages. Then, when sunlight finally hit it in our system, the first breath would carry the colder volatile out in strength. Rare does not mean impossible. Rare means interesting. The coma shape adds a second wrinkle. With normal heating, gas boils off the sunlit side and spreads into a large, diffuse cloud. 3i Atlas showed a comparatively compact and structured coma for its brightness, as if the venting was focused or limited to tighter regions. Think of a kettle with a few sharp spouts instead of a pot steaming everywhere at once. Focused activity can come from topography. Deep pits and cliffs funnel gas like nozzles. It can also hint at regulation rather than chaos. Put both clues on the table and two pictures appear. Picture 1 is a nucleus that formed in a deep freeze and kept its crust sealed until sunlight woke a few easy outlets. That yields high carbon dioxide and a tight coma without any trickery. Picture 2 is a layered shell where the volatile mix and the vent placement are properties someone chose. You bury hardware under meters of ice and rock. You use materials that keep a low profile until a target star warms them. When they do, the behavior reads as comet, like to a first glance, while still leaving a trail of odd ratios and tidy jets for careful eyes. We should be strict about confidence. Not all reports come from the same instruments or teams. Some measurements carry larger error bars than others. Weather, background light, and calibration drift can nudge ratios around. A single night can paint a different picture than a week-long campaign. The responsible move is to treat the chemistry as a pattern across multiple observers rather than a verdict from one dataset. When the same song keeps trying to play through different speakers, you can start humming along. There is also the timing game. Volatile ices do not all wake at the same distance from the sunday. Carbon dioxide can start flowing when water is still shy. That means early spectra can make a comet look carbon heavy, then later measurements tilt back toward water as the surface warms more deeply. If your window onto a fast visitor is narrow, you might catch only one act and mistake it for the whole play. That is why light curves and spectra need to be woven together. Brightness changes tell you when vents switch on. Then there is dust. Fine grains launched with the gas can change how the coma looks. Backscattering near the sun can make a small coma look brighter. Large grains can hide the gas lines by shining in reflected light. To peel gas from dust, you choose wavelengths where the dust is dim and the molecules sing loud. If the molecules still insist on the odd mix, the chemistry case strengthens. What would be the engineering tells in chemistry? A narrow feature that does not belong to common volatiles. A modulation in emissions that tracks with a rotation, but looks too clean to be random geology. An outgassing pattern that responds to timed illumination experiments. For example, a coordinated set of observations when the object passes in and out of Earth, based radar or laser illumination windows, showing effects beyond solar heating. None of those are easy to claim. All can be hunted without drama. Comparisons help keep perspective. Oumuamua was chemically quiet but dynamically odd. Borisov was a textbook comet with a pleasing spread of familiar volatiles. 3I Atlas sits between them, ordinary enough to live in the comet family photo, odd enough to catch the eye of the relative who has seen too many reunions to be impressed by stale cake. That is exactly where interesting science likes to live, on the thresholds where categories start to blur. So where do we land for now? With a visitor whose breath smells more of carbon dioxide than expected, whose steam is tighter than average, and whose combined quirks are consistent with deep cold, with topographic vents, and with the possibility of deliberate disguise. The next moves are simple to say and hard to do. Reanalyze spectra with fresh calibrations, cross-check gas and dust models against the light curve. Look for repeating details that stick around through changing geometry. The chemistry will not hand us a confession, but it can lean the balance. It already has. Ask the simplest mischievous question. If you wanted to visit a young and jumpy civilization without causing panic, what would you look like? Not a shining craft with sharp edges and beacons. You would dress as scenery. In a solar system full of stone and ice, you would look like stone and ice. You would follow a path that gravity could explain. You would breathe gas when warmed by sunlight because that is what comets do. You would not announce yourself. You would let the patient and the curious find you. Disguise is not magic. It is logistics. A shell of ice and dust is free armor that space hands you. It blocks radiation, hides heat, and smothers sharp spectral fingerprints. Bury anything delicate a few meters deep and the surface behaves like a small world. Sunlight hits. Pits and cracks vent like nozzles. Dust rides the gas and makes a soft halo. The whole performance reads as comet to a first glance. The trick is not to look perfect. The trick is to look normal enough that only long attention notices the seams. Why choose ambiguity instead of spectacle? Because ambiguity gives everyone room to think. A loud arrival would force a political crisis on a species that has barely learned to keep satellites from colliding. A subtle arrival turns the story into science. Observers argue. Teams test. Ideas compete in daylight. The psychological load shifts from fear to curiosity. If the goal is to meet minds rather than trigger reflexes, you design for slow recognition, not instant awe. So, what would a cautious probe want from its costume? It would want to control when it sheds gas to avoid obvious thrust signatures. It would want vents that open at predictable thermal thresholds so that solar heating can take the blame. It would want a mix of ices that wake in stages, so activity feels like layers of geology rather than switches flipped by a hand. It would want a crust that holds together well enough to avoid dramatic fragmentation mid-passage. Quiet is a feature. Communication undercover would also be quiet. A device hidden inside an icy shell does not need to broadcast powerfully to the whole sky. It needs to whisper in tight beams to places already chosen. The shell would absorb most of the heat from any gentle transmission, leaving the global energy budget looking like sunlight in and sunlight out. If you were sitting on Earth watching, you would see a normal thermal curve with no extra furnace glow that screams engine. How about navigation? A disguised visitor does not dogfight. It coasts. The cleverness happens at the start. You pick a path that passes through the target system without needing late course changes. You let gravity shape most of the story, then hide any tiny corrections inside natural outgassing. To a telescope, that reads as a standard non-gravitational drift, the kind analysts already fit when comets vent as they spin. The difference would be discipline. The pattern might be tidier than nature usually manages. Are there tests for a costume like this? Some are delightfully low drama. Watch the light curve through many rotations and look for repeating fine structure that is too clean for rough topography. Measure the polarization of scattered sunlight as the phase angle changes, and see whether the dust behaves like familiar comet dust or like something more uniform. Compare dayside heating and nightside cooling to infer thermal inertia. A shell that hides internal heat sources may show strange lags, or a stubbornly even temperature that resists the usual day-night swings. You can also try polite knocks, not a broadcast to the galaxy, just timed hails aimed along the outbound path when the geometry favors a reply. You publish the plan so any receiver can anticipate it. Then you watch at many wavelengths for tiny, repeatable changes after the hails that cannot be blamed on solar activity. The goal is not spectacle. The The goal is a nudge that passes the boring test 3 times in a row. Critics will say that any single oddity can be natural. They are right. Crusts crack, vents focus, dust fools instruments. That is why the disguise hypothesis lives or dies by accumulation. 1 anomaly is a story. 3 independent, repeatable anomalies that agree across teams begin to look like design choices. The threshold is not one eureka moment. The threshold is a quiet stack of boring, reproducible facts that point in the same direction despite different methods. There is also an ethical lens. A cautious sender would avoid contaminating the target system. A stone and ice shell is biodegradable by cosmic standards. After the pass, the object returns to the dark. If the shell sheds anything, it is dust that behaves like dust. No metallic wreckage. No radioactive surprises. Nothing for a nervous species to weaponize. The costume becomes a safety policy as much as a mask. So where does this leave us with 3i Atlas? The chemistry is odd, but not unique. The coma is compact and structured. The path is plausible under gravity, and stubbornly untraceable beyond a district. All 3 are exactly what a careful disguise would produce, and also what a deep freeze comet could produce. That is the point. A good costume hides inside the statistical noise of nature. The only way through is patience, coordination, and tests designed to reward replication over drama. Hold the image of a traveler wrapped in ice, letting sunlight write the cover story while deeper instruments do their work. If that picture is wrong, the test will fail gracefully, and we will file the visitor under rare but natural. If that picture is right, the same tests will keep whispering yes in different dialects until even the skeptics feel the pressure of agreement. Either way, the disguise hypothesis gives us practical questions and honest outcomes. That is science dressed for the long game. Think of the Milky Way as a sprawling city. Spiral arms are neighborhoods, quiet to bustling. The center is the old downtown where everything crowds together and history piles up. When you face the Archer, you look down the main avenue toward that downtown. Star, Count Spike, ancient giants drift beside hot newborns, clouds that make stars glow like neon. If you wanted to find a place where many stories cross the same street, you would plant your feet here. Busy is not poetry, busy is statistics. More stars means more disks that once circled newborn suns. Disks make planets, planets make comets, and asteroids by the trillion. Give chemistry enough throws of the dice, and life gets many chances to begin. Give time enough runway and some of those lives learn tools. That is the quiet logic behind calling the Archer a hub. It is not that the constellation itself is special. It is that the direction points through the thickest part of the stellar market, where chance keeps dealing new hands, and where old players may have been seated for ages. There is a second reason hubs form. They accumulate infrastructure. On Earth, ports grow where sea lanes meet and where currents help the work. In space, a parallel idea appears. If you wanted to watch for newcomers without spending absurd energy, you would pick sightlines that sweep the most stars. If you wanted to power big machines forever, you would anchor near reliable energy sources and long-lived orbits. The deep center offers both. It is harsh in places, yes, but harsh can be managed by those who have had eons to learn the local weather. Geography matters for traffic too. Our solar system skims the galactic disk like a bead on a wire, drifting around the center on a path that takes hundreds of millions of years to complete. Objects approaching from the Archer direction do not fight that geometry. They meet us head-on along a long hallway where relative velocities line up for clean intercepts. You do not need exotic engines to arrange a meeting in such a hallway. You need patience, a careful launch, and the willingness to let gravity do most of the steering. Now picture how a cautious network would announce itself across deep time. You place quiet watchers where the viewshed is, enormous. You listen more than you speak. When a young species lights up its local sky with radio and radar, you do not swing a spotlight into their eyes. You give them a breadcrumb near a universal signpost. Later, you route a physical visitor along a lane they already map for scientific reasons. The Archer becomes your bulletin board because the students already face that wall. None of this requires a grand conspiracy. It requires convergent problem solving. Sailors who never met still learn the same currents. Engineers who never met still aim at the same stable orbits. Astronomers who never met still choose the same bright spectral lines and the same crowded windows of sky. If older minds once built way stations in this galaxy, they would gather where the lanes cross most often. If they left nothing but habits behind, later minds would rediscover those habits on their own. Either path makes the archer feel like a hub from our point of view. There is a humility check to keep in pocket. Sagittarius covers a big patch of sky. It is easy to romanticize a match between a line of direction and a myth on a star chart. That is why we keep translating the romance back into geography. High star density. Long histories. Many places for tools to arise. Many chances for traffic to line up with our path. When you strip away the centaurs and archers, the practical map remains. There is also a reason this hub idea helps without overpromising. It gives us testable behaviors. If a lane exists, we should see more interstellar traffic from these busy bearings as surveys improve. If infrastructure exists, we might see repeating oddities in similar directions across different years. If nothing special exists, the pattern should fade as our sample size grows and the sky evens out. Hubs either focus traffic or they do not. The numbers will tell us which. So hold the image of downtown, a district thick with tenants, alleys, courtyards, and long sightlines. Our instruments already linger, there because it is beautiful and because it is informative. Our radio bubble has washed into that view, not by destiny, but by simple expansion. A clean, narrow ping once rang from there, at the universal frequency school children learn to calculate. A one-time visitor now appears to trace back into the same lantern glow. You do not need to declare intention to admit the pattern is interesting. You only need to keep watching the crossroads and keep count honestly as traffic grows. Begin with a calendar page that should not matter, and yet does. Mid-August, 1977. In Ohio, a telescope listening at the hydrogen line hears a narrow burst that lasts about a minute and then vanishes. 5 days later, on a Florida launch pad, a slender rocket lifts a small robot called Voyager 2 that carries a golden record with music and greetings for any mind that might someday find it. Signal in. Message out. 2 moments, 1 week apart. Coincidence or cadence? The radio event came first, a clean tone at the universal frequency where hydrogen whispers. It rose and fell in the exact way you would expect from a real source drifting through a fixed beam as Earth turned. Then it was gone. No repeat to comfort the cautious. No follow-up to let us triangulate. Just a single, perfectly placed knock from the general direction of the archer. A hello that refuses to grow old because it refuses to grow at all. Then came the launch. Voyager 2's path tilted outward past the giant planets. A multi-year tour that would end with the craft slipping beyond the planets into the great dark. Bolted to its frame was a copper disc sealed in aluminum, encoded with 116 images, 90 or so minutes of music, natural sounds from wind and surf to thunder and birds, and greetings in 55 languages. The cover held a diagram that any physicist could unpack with patience and a little luck. It was not a beacon. It was a message in a bottle entrusted to physics and time. Look at the symmetry and tell me it does not itch the parts of the brain that hunt patterns. A week before we throw our message toward the same broad sky, a brief tone from that sky taps our attention. The two do not meet in space. Their paths never cross, but they rhyme. One says we are listening, the other says we are speaking. If you wanted to choreograph a gentle first act of contact, you could do worse than this pairing. No demands, no coordinates, just mutual awareness, implied by timing and restraint. So, where exactly is Voyager 2 going? Its outbound trajectory aims generally below the plane of the planets, on a long arc that projects toward the constellations around the southern sky, including Sagittarius and Pavo by long-term reckoning. That is not a precise destination. It is a heading, a direction for a traveler that will take tens of thousands of years to come near another star. The record it carries is meant to last far longer than the civilization that sent it. We did not expect a reply. We barely expected a finder. And yet the logic of the week makes a different thought impossible to ignore. What if the reply came first? Not a translation of our music, not a transcript of our greetings, just a one-time tone delivered at the obvious frequency a few days before our own emissary left the cradle, a polite nod from the general direction where our telescopes already dwell. A way to say we see you without risking anything more than a momentary flash at a universal channel. The golden record matters beyond romance. It forced us to choose what to say when the universe gives you only a few minutes of attention. We did not send a manifesto, we sent art, anatomy, mathematics, and the sound of a heartbeat. You could call it naive. You could also call it honest. It says we are a species that tries to understand and to celebrate. It says we know we are small and temporary. and we are speaking anyway. That tone from the archer, if it was a nod, carries a similar humility. No speech, no chest beating, just present. There is a hard-nosed version of this story that still preserves the charge. The tone could be natural. The launch date was set by engineering and orbital windows, not by a cosmic poet. Symbolism does not prove anything. True. Yet science is guided by human attention, and attention is guided by story. When unrelated facts arrange themselves into a rhythm that invites a better test, you take the invitation. You do not declare a miracle. You sharpen your questions. Here is the practical edge of the symmetry. If a cautious watcher wanted to structure a slow conversation, a clean ping followed by a silent decade and then a physical passerby would be a credible plan. The first touchpoint is trivial to deny. The second invites observation without terror, and the whole sequence sits along a direction that already draws our gaze for reasons entirely our own. The choreography hides inside our habits. We discover it only when we step back and notice how the beats land. The week in 1977 will always feel like a hinge. On one side is an Earth that had barely learned to keep a spacecraft alive beyond the orbit of Mars. On the other is an Earth that began to imagine its culture lasting as a small disk crossing cold space. The tone in the radio log and the small robot under the fairing are both acts of faith, one perhaps from us, one perhaps to us. Neither proves the other. Together they dare us to keep looking down that lane with clearer eyes and steadier hands. Here is where the pattern stops looking like a headline and starts looking like a plan. Imagine a playbook used by careful civilizations that have watched many worlds wake up. Step 1 is passive listening. Do nothing dramatic. Just map the radio sky for decades and wait for a new world to leak its presence. Step 2 is a single knock at the universal door. A bright, narrow ping at the hydrogen line once, clean enough to be noticed, brief enough to be deniable. Step 3 arrives much later. A physical visitor that looks natural, invites study, and never forces panic. If you squint at our timeline, you can see these beats. Why would anyone design contact this way? Because shock breaks trust. A floodlit reveal demands instant political decisions from a species that still argues about orbital debris. A quiet reveal gives science room to breathe. It lets curiosity lead, not fear. The choreography is not about hiding forever. It is about pacing the conversation, so a young culture can keep its footing while it learns to ask the right questions. Start with the listening stage. A mature watcher can park small instruments in stable orbits and sweep the sky for regular, narrow carriers that only engineering makes. They do not need to transmit. They only need patience. When a planet's radio bubble touches their sensor range, they mark the time, note the direction, and begin a slow watch for growth. The signature strengthens year by year as more satellites launch and more radars blink. Noise turns into a profile. The watchers now know a new partner exists. Then the knock. A one-time ping at the hydrogen line is the perfect test. It costs little energy. It reveals almost nothing about the sender's location. It lands exactly where beginners listen first. Most important, it teaches the watchers something vital about us. Do we notice? Do we check again? Do we argue without losing interest? A single clean tone at a universal frequency is a way to measure vigilance without forcing a treaty meeting. If the knock is heard and archived, the choreography moves to the long beat, a physical passerby, not a caller that parks over a capital. A single object on a path gravity can explain. It should be bright enough to study, but not so flamboyant that headlines drown out data. It should contain ambiguities that reward careful measurement. Chemistry slightly off the center line, a coma that acts a little too tidy. A trajectory that backtraces to a district, not a dot. Each detail is ordinary enough to shrug off, but together they sketch a silhouette. Recognition becomes a function of attention. Some will see malice in such restraint. Why not just talk? Because broadcasting openly carries risks for both sides. Shouting advertises your position to every ear, friendly or not. Speaking in riddles is not cruelty if the riddles are solvable with tools the listener already owns. The choreography trusts us to earn the answers with method, not mythology. Plausible deniability is not a trick. It is a pressure valve. If the world is not ready, the story dissolves into natural explanations without leaving scars. If the world is ready, the same data form a ladder. We climb one rung at a time. Passive listening turns into targeted campaigns. The knock turns into a hypothesis we can test. The passerby turns into a program to intercept the next one. The pace matches our own competence, not theirs. What would the next beats look like if this model is real? Expect redundancy rather than crescendo. Another narrow ping years from now, perhaps at a related natural line. Another visitor from a similar bearing once our surveys improve, odd in a familiar way. An invitation to notice patterns across objects rather than inside a single celebrity rock. Nothing so obvious that it forces belief. Enough that disbelief has to work harder each season. There is a more demanding possibility tucked inside this plan. It asks us to participate, not with faith, but with discipline. Publish observing windows in advance. Coordinate multi-band campaigns along predicted paths. Reprocess old spectra with fresh models. Attempt polite, time-stamped hails when geometry favors them, and pre-register the protocol so any reply would be recognizable to every team at once. The choreography is only a dance if both partners move. The counter-argument remains healthy. Maybe a knock is a natural burst. Maybe a visitor is just a cold, ancient migrant. Good. The choreography survives that scrutiny by design. It is a hypothesis that lives on reproducible tests, not on a single spectacle. If the pattern fades as data grow, we learn something honest about how easy it is to fool ourselves. If it sharpens, we learn something larger about how cautious minds say hello. There is one more reason to respect the slow pace. Time is the only constant every civilization shares. Light needs time. Orbits need time. Minds need time. A plan that honors time is a plan that can work across species and across centuries. It is not cinematic. It is wiser. The triple convergence we began with becomes less like a coincidence and more like the opening of a long conversation whose sentences take decades to finish. So hold the steps in order. Listen first. Knock once. Send a passerby that plays fair with physics. Then watch what the newcomers do. Not because you need their answer today, but because the answer you want is not yes or no. It is whether they can turn wonder into method without losing the wonder. That is the heart of cosmic choreography. It is not a trick to fool us. It is a test to show us, to ourselves. Hold up the mirror and ask the only question that matters. If someone out there is cautious and patient, are we the kind of species they would want to talk to? Not our best myths, but our habits under pressure. Do we notice quietly? Do we replicate carefully? Do we share data instead of hoarding headlines? Contact is not a door we kick open. It is a test of whether we can act like grown-ups when wonder knocks. Start with the simplest physics teacher in the room. Time. Light needs it. Orbits need it. Minds need it. A signal sent from 30 light years away left before many of us were born. Our reply would arrive after many of us are gone. That delay is not a bug. It is the rule. Round trip means patience becomes part of the protocol. So the mirror asks whether we can sustain attention across years and decades. Can. We keep files organized, instruments calibrated, and curiosity intact after the news cycle moves on. Now, the content problem. What should we say if we choose to say anything at all? The debate between listening only and messaging on purpose is not a cartoon. Broadcasting loudly to the whole sky advertises our position to friends and strangers alike. Whispering in narrow beams along a known outbound path is much safer and still honest. The mirror pushes us toward humility. If we speak, we keep it simple and universal. Mathematics, timing markers, a clear description of when and where we listened and when we replied. No chest beating, no secrets slipped into the fine print. There is a second layer to the mirror. Process. A responsible response looks less like a single heroic transmission and more like a public experiment. You pre-announce the plan so that every observatory in the world can prepare to watch the same windows. You timestamp the moments when the hails go out. You publish the exact frequencies and modulations used, so any reply can be recognized independently and not argued over as a private catch. You invite skeptics into the design so that if anything interesting happens, the first check has already been passed. We can act today without waiting for permission slips. Reprocess archives with fresh eyes and better models. Old spectra and light curves may hold patterns that no one thought to test because no one had this hypothesis on the table. Coordinate citizen scientists with professionals so that the sky is covered even when the biggest mirrors are clouded out or booked. Build a living map of the outbound path with predicted geometry and best times for polite hails. None of this requires belief. It requires craft. The mirror also asks for discipline when nothing happens. Most nights will be quiet, most tests will say no effect. The mature move is to publish those null results with the same pride as the rare maybe. Negative space is information. It narrows the field of possible stories. It keeps us honest about how easy it is to chase noise. It proves we are builders of knowledge, not hunters of headlines. Who speaks for Earth? The fairest answer is no one alone. The next fairest answer is everyone in public. A small group can draft a protocol. A large group can refine it. The whole world can observe it. If a reply ever lands, there will be time for diplomats and poets. First, we need engineers and statisticians, and the boring heroism of version control. The mirror is not asking for a world government. It is asking whether we can run one careful experiment together without tripping over our own egos. There is another kind of message already leaving us whether we transmit on purpose or not. It is the shape of our spectrum, the rhythm of our satellites, the way our radars blink. Any watcher who can detect that pattern already knows two things about us. We can coordinate complex systems, and we sometimes fail to. They can see the clutter, the debris, the occasional near miss. They can also see the elegance of a gravity assist and the beauty of a well-tuned antenna. The mirror says this too is a conversation. Our engineering is a language. So what does a dignified first move look like from here? We keep listening along the lane where our own bubble has reached. We design a few carefully timed hails aimed not at the galaxy, but along the path of the departing visitor. We prepare to catch tiny changes that repeat across independent teams. We keep the bar high and the door open. If the answer is silence, we learned how to run a global experiment. If the answer is a whisper, we will be ready to hear it. The last question in the mirror is personal. Can we hold wonder and skepticism in the same hand without crushing either one? That balance is the signature of a culture ready for a larger conversation. It says we are not easy to fool and not afraid to hope. If someone is indeed watching to see how we handle ambiguity, that is the trait they are looking for. Not genius or bravado, patience with spine. We are already speaking every day whether we intend to or not. The mirror invites us to do it on purpose, with care and with the long game in mind. If the triple convergence is choreography, we have been called to the floor. If it is coincidence, the practice will not be wasted. Either way, the next move is ours, and the universe has time to wait while we make it well. Let us tune the instrument before we play the song. Skepticism is not a brake, it is the steering wheel. We use it to keep the story on the road when the scenery gets weird. If a pattern survives a hard drive through the potholes of doubt, it deserves your time. If it falls apart, good. We just saved ourselves from an expensive mirage. Start with the easiest trap, survey bias. We look toward the archer more often because it is beautiful and rich. More looks mean, more finds. That can fake a hotspot even when the sky is honest and indifferent. The cure is counting windows as well as wonders. How many hours did we stare here versus there? What was the sensitivity floor on each night? What weather and moonlight did to our reach? Until we compare finds against exposure, we are just telling campfire stories about constellations. Next trap. Instrument personalities. Every telescope and receiver has quirks, side lobes that let in a whisper from off-target, clocks that drift, filters that age, software that assumes answers before it has earned them. A clean tone can be a local glitch wearing a cosmic mask. The fix is redundancy. Different hardware, different teams, different pipelines. When a strange feature survives those switches, it graduates from rumor to result. One time, events carry special risk. Non-repeating does not always mean intelligent or unique. Lightning in the upper atmosphere, a reflection off space junk, a forgotten transmitter, even subtle refraction in the ionosphere, can all paint temporary lines on our plots. The safe posture is boredom first. Assume noise, then peel it away with repeated checks. If the signal refuses to die after that, then we talk. Orbital rewinds have their own gremlins. Tiny errors grow with time. A missing tug from an uncatalogued mass turns into a large miss a million years back. You can hide nearly anything in a big enough uncertainty cloud. That is why we publish the cloud, not just the pretty center line. The honesty lives in the spread. Wide spreads mean shrug, not revelation. Chemistry can mislead too. Spectra depend on calibration that drifts, and on how we remove Earth's own air from the data. Dust scatters light in ways that hide or mimic gas lines. Rotation changes which vents face us. Phase angle changes how bright the dust looks against the gas. A single night can make an object seem exotic. A week can make it look tame. The antidote is time series and cross-checks. If the odd ratio repeats across nights and instruments, then we lean in. If it melts when we clean the calibration, we lean out. Confirmation bias is the quiet thief in the lab. Once you love a story, your eyes get sticky for evidence that feeds it. The fix is dull but powerful. Pre-register what will count as interesting before the telescope opens. Freeze the thresholds for claiming a detection. Hold back a chunk of data as a blind test and do not touch it until the method is locked. Invite the loudest skeptic to help write the plan. If they agree the plan is fair, you just bought credibility that a press release cannot fake. Beware the after-the-fact prophecy. Humans are masters at drawing a bullseye around the arrow once it has landed. We can connect any 3 dots if we try hard enough. The defense is statistical humility. Compare your pattern against a control sky. Run the same search on scrambled data to see how often randomness imitates your signal. Demand that a claimed anomaly beat those doppelgangers by a wide margin, not by a hair. Null results are not a failure. They are the floor that holds up the room. Publish them, archive them, make it easy for the next team to avoid your dead ends and to test their own ideas against your quiet nights. When a maybe appears, the first question should be whether it survives contact with the pile of already published nothing. If it does, the maybe gets a little louder. Extraordinary claims demand a higher ladder. That does not mean we are hostile to wonder. It means we refuse to confuse surprise with proof. A single odd spectrum cannot carry the weight of alien hardware. A single ping cannot carry the weight of welcome. We ask for the slow gold of replication. The same effect, measured by different people with different tools under different skies. Here is our pact with you. We will change our minds in public. We will retract cleanly if a beautiful idea fails a boring test. We will celebrate a debunk that saves time as loudly as we celebrate a detection that changes minds. The channel does not need the universe to be magical. The universe already is. Our job is to keep our own brains from adding glitter where none belongs. So bring the doubts, sharpen them, use them, let them cut false stories to the bone. If a pattern remains standing after that work, it is not fragile. It is ready for the next step. Curiosity and skepticism are not enemies. They are partners with different jobs. One pulls us forward. The other keeps us from falling. We need both hands on the wheel for the miles ahead. We have reached the point where human patience needs silicon stamina. Artificial intelligence can stare at skies we have already recorded and ask questions no graduate student could finish in a lifetime. Machine learning can sift billions of measurements, search for patterns in directions, speeds, and detection times, and tell us whether interstellar visitors arrive like random rain or like a scheduled train. But here is the razor's edge. The same tools that find real structure are experts at finding ghosts. We must build the hunt, so a computer cannot fool us with our own data. Begin with the raw ingredients, star catalogues with precise distances and velocities, survey logs that say where telescopes looked and for how long, detection lists for every fast-moving speck ever flagged as unusual. Feed these into a model that learns to predict what a purely natural sky should produce. Then ask it to flag nights and sightlines where the real world strays too far from the expected. If the deviations cluster toward the Archer in ways exposure time cannot explain, now you have something worth losing sleep over. What would a genuine pattern look like? Directions that repeat beyond what the survey footprint predicts, arrival speeds that fall into narrow bands when they should be wide, seasonal clustering that remains after you correct for weather and moonlight, subtle alignments with our own orbital position that make sense for interception geometry, but not for random passers-by. You want coincidences that keep lining up even after you remove every boring cause you can think of. Now, the trap. Surveys do not see the sky fairly. Telescopes rest on mountains with weather and seasons. They avoid the moon. They stare where the funding asks them to stare. Wide-field cameras hunt in strips that repeat in the same months each year. An algorithm that ignores this will happily discover that more objects appear where we actually looked. That is not a message from the galaxy. That is a mirror held up to our schedule, so we do not let the model judge the universe naked. We dress it in our biases on purpose. We simulate fake skies full of natural objects and push them through a virtual copy of our instruments with the same nights, the same clouds, the same limits. Then we see how often those fake surveys produce a pattern as strong as the one we think we see. If the answer is often, we were chasing our own habits. If the answer is almost never, the hairs on your neck have earned the right to stand up. There is another safeguard: pre-registration. Before running the big jobs, we write down which patterns would count as interesting and how strong they must be. Perhaps a cluster in arrival directions tighter than a certain angle after exposure correction. Perhaps a velocity spike at a specific range that repeats across independent surveys. We lock those thresholds, then press go. If the results miss, we publish that miss. If they hit, we let other teams rerun the pipeline on the same public inputs. The excitement begins only when a stranger's computer says the same thing. Injecting phantoms is powerful too. We plant a handful of synthetic interstellar objects with known properties into archived images and hide the list from the analysis team. If the pipeline recovers the fakes at the right rates and does not hallucinate extras, we trust it more. If it misses the fakes or sees patterns that are not there, back to the workbench. In a field where we crave strange answers, controlled boredom is a superpower. Artificial intelligence can also help beyond statistics. It can read spectra and light curves like a multilingual librarian. Unsupervised clustering can sort thousands of cometary behaviors into families and spotlight outliers that deserve telescope time. Anomaly detectors can watch for tiny periodic flickers that human eyes ignore. But caution again, many instruments share subtle systematics. A neural network will learn those first. Only after we scrub and augment the data to break those shortcuts will the network earn permission to tell us anything about the sky. The most exciting outcome would be a necklace. Not one celebrity object, but a string of them. Multiple interstellar visitors arriving over decades from bearings that trace a gentle cone around the Archer. Speeds that suggest a common launch corridor. Activity patterns that rhyme. Each bead alone is debatable. The string is not. That is the kind of structure artificial intelligence might reveal if it exists. And if the models find nothing but dust and chance, that is an answer with weight. It would mean the triple convergence is a lesson in human pattern hunger, not in cosmic choreography. It would also mean our tools have grown sharper. The next visitor will not slip past unmeasured, because the software was daydreaming. So we ask the machines to help, but we do not hand them the keys. We insist on transparency, on open code, on public data, on independent reruns. We measure our confidence not by how cool the plots look, but by how easily a skeptic can reproduce them. If a real pattern is hiding in our archives, artificial intelligence will find it faster than we can. If it is not, artificial intelligence will teach us to stop chasing shadows and to point our biggest mirrors at the next honest mystery. Picture a breadcrumb trail laid across a windy plain. Walk backward and the breeze smears every step until the path becomes suggestion rather than map. That is what happens when we rewind an interstellar trajectory across millions of years. The math is cleaned. The universe is not. Tiny forces you cannot point to on a chart accumulate into real detours, and the past dissolves into a cloud of maybes. Start local. Gravity from the sun and planets is known with remarkable precision, so near-term rewinds are solid. The wobble begins when you reach beyond the tidy clockwork of our system. The galaxy itself applies a slow tidal pull that nudges long-lived orbits. Passing stars add brief shoves that we cannot always reconstruct, because catalogues of stellar motion grow thinner the farther and older you look. Drift through a vein of interstellar gas or brush the faint grip of a molecular cloud, and you gain another whisper of acceleration. Each whisper is harmless on its own. Stack them over a span longer than humanity has had cities, and you get a memory that will not quite play back. Now fold in forces that are not pure gravity. Sunlight warms a rotating body and makes some surfaces vent more than others. Those jets act like microscopic thrusters, and they couple to spin in awkward ways. Seasonal heating can tilt a path gently over months. Radiation pressure pushes dust and fine fragments, and even a big nucleus can feel a tiny, steady shove if its surface is lopsided enough to catch light unevenly. None of this is cinematic. All of it is cumulative. When you push the rewind far enough, unmodeled breaths become miles. Then comes the invisible mass. Dark matter is the name we give to gravity whose source we cannot see. On galactic scales, it behaves like a smooth background that keeps stars bound to the Milky Way. On smaller scales, we do not yet know how lumpy it is. If there are thin streams or mild clumps sliding through our neighborhood, a traveler that wanders for eons will feel their pull. The effect is tiny at any instant, yet not zero. Over deep time, not zero matters. You can explain a lost origin with nothing more exotic than this mishmash of low-level nudges. There is comfort in that humility. Old things forget where they came from. A smeared rewind is what you expect for an object that has been adrift since long before humans shaped metal. That is the natural reading, and it is strong. It lets us avoid reaching for miracle physics every time history goes fuzzy. It also sets the bar for any claim of intention. To beat old and scrambled, you need a pattern that resists the smear. Here is the speculative window that will not close. Advanced navigators might use the very structure that confuses us as a map. In the inner solar system, engineers already use low-energy paths called manifolds, graceful tubes in the gravity of 3 bodies that let spacecraft surf from one neighborhood to another with thrift instead of brute force. Scale the idea up. The galaxy contains spiral density waves, stellar streams, and stable corridors in its overall potential. If you launch along a groove where geometry and gravity cooperate, you can drift a long way with very little push and arrive at a predictable crossing with our path. No warp drives, just patience and choreography. That idea buys you more than efficiency. It buys you cover. A probe that rides invisible rails looks like a natural drifter when seen from afar. Rewind its path and you do not find a clean parent star because the launch was chosen to dissolve into the background when integrated backward. The signature of design becomes statistical rather than theatrical. Arrivals cluster along lanes that match galactic structure and relative motion rather than distributing evenly across the sky. The Archer direction fits this geometry well. Our system circles the galactic center and slides through the disk. Meeting us head-on from that corridor requires less drama than catching us from a high angle. The relative velocities align. The timing windows are forgiving. A navigator who thinks in millennia would prefer such a hallway because the physics smooths errors. That does not prove anything. It does explain why repeated alignments with this bearing do not need magic to feel natural. How do we test the noise story against the rails story? First, tame the uncertainties we can control. Recovery images shrink present-day error bars and make every rewind less chaotic. Better modeling of non-gravitational drifts turns a hand wave into a number. Radar ranging during close passes locks down distances that ground-based angles alone cannot. Second, look for population-level signatures. Do future interstellar visitors favor a cone in direction and a band in speed after we correct for where surveys actually looked? Do their motions line up with known stellar streams in our region? If yes, that leans toward corridors. If no, that leans toward random rain. There is a third path that sits between the two. The galaxy is messy but not pathless. Natural debris will also prefer lanes carved by structure, simply because that is where orbits herd them. In that case, the test becomes sharper. Design traffic should be tidier than debris, with tighter clustering and cleaner timing. Debris should be fuzzier, with wider spreads and more noise after bias correction. This is where statistics matter more than anecdotes. The take-home is simple and demanding. You do not need exotic engines to lose a birthplace. Time and tiny forces will do. That is the sober baseline. You also do not need new physics to imagine long-planned routes that hide in plain sight. That is the intriguing alternative. The way forward is measurement and patience. Shrink the present errors, publish the full uncertainty clouds, and let growing samples tell us whether we are watching dust on the wind or traffic on a road we are only now learning to see. Picture 2 kinds of conversation. One kind shouts across a room with a bullhorn. The other whispers through a private line no one else can tap. For a century, we have been listening for bullhorns, radio beacons, laser flashes, signals that spray energy into space where anyone with a dish could eavesdrop. But mature civilizations might prefer the other kind. Networks that carry meaning without spilling much energy into the open. If the galaxy mostly talks that way, our antennas would hear almost nothing. Silence would not mean nobody is speaking. It would mean nobody is leaking. Start with an idea we already test in orbit. Quantum key exchange. You create pairs of particles whose properties are linked. Separate them by thousands of kilometers. Measure 1. The correlations show up in the other. You cannot read the message without being part of the system. Try to snoop and you break the link. The important part is simple. To outsiders, the line looks empty. Information lives in the correlations shared between the endpoints. A city of light could hum with traffic, and you would not see it from the sidewalk. There are other leak-free tricks that do not require deep quantum jargon. Tight, laser beams thinner than a planet, spread spectrum signals buried under the noise floor. directional bursts that last a heartbeat and never repeat, all share one goal: keep the content between sender and receiver while leaving almost nothing for bystanders to detect. A newcomer with only blunt ears hears the cosmos as a whispering crowd behind a wall. So where does our famous one-time ping fit? Here is a possibility that does not ask for miracles. You run a mostly quiet network. One node glitches. For a minute, a bit of energy couples into a classical frequency that any beginner would notice. The hydrogen line. A bright, narrow tone pops out. It looks deliberate because it lands on the universal signpost. It looks unique because the fault ends quickly. From the network's point of view, the event is boring. A brief alarm. From our point of view, it is the loudest thing we have ever heard. This is not the only way to hide in plain sight. You can bundle content into the structure of a physical object and move it slowly rather than broadcasting at all. A disguised visitor becomes a storage drive on a long delivery route. No emissions needed, no leaks to intercept. The message is the artifact itself. If you are ready to read it, you will. If not, nothing explodes. The sky stays calm. The network remains invisible. Why would anyone choose quiet over flash? Security is one answer. Shouting paints a target on your back for every ear within range. Efficiency is another. Power spent spraying the void is mostly wasted. Precision beams and shared keys waste far less. There is also culture. Old networks drift toward minimal surface area. They reduce attack vectors. They leave smaller footprints. If galactic conversation is older than we are, it likely learned those lessons long ago. What could we test today without fantasy tech? We can look for side effects rather than content. A whisper network still needs clocks and standards. It still needs stable platforms. That means you. Search for objects that hold unusual pointing stability or odd thermal regularity without any good natural cause. You monitor for repeating microflashes that are too clean to be lightning and too brief to be satellites. You stack years of data to hunt correlations between widely separated sites that move in lockstep on suspicious timing grids. You do not decode. You only ask whether something coordinated is there at all. We can also flip the roles and become a polite endpoint. Publish a narrow set of times and frequencies for outbound hails along the path of a departing visitor. Keep the power low. Keep the beam tight. Announce the plan so everyone can watch at once. If a reply lives in a leak-free layer, it could choose to answer with a tiny, pre-agreed change we can all check. A micro-dip in brightness. A slight modulation of a coma line, the kind of nudge that would be trivial for a node and unmistakable to a world that prepared. Skeptics will say, this is castle building on fog. That is fair. Quiet networks are hard to prove by design. Yet the idea earns a place at the table for one practical reason. It explains the silence without accusing the universe of emptiness. It turns our job from waiting for a shout to setting traps for coordination. We look for rhythms rather than speeches. We publish our metronomes and invite the sky to tap back. There is a final twist. Even if the galaxy whispers, our own house is getting louder in clever ways. We can build instruments that measure faint correlations across continents. We can share time with atomic clocks that agree to absurd precision. We can crunch years of data for patterns no human eye could spot. Leak-free does not mean unfindable. It means the test must be crafted with care and run in daylight so that a repeat can bless the result. If the universe prefers quiet lines, we may already be standing next to one without knowing it. The cure is patience, transparency, and the courage to publish nothing when nothing is what happened. When a something finally appears, it will be small, repeatable, and beautifully dull. That is how truth looks when a world is ready to see beyond its own noise. Listen to the universe with different ears, and you hear it ring, not with sound but with ripples in space itself. Over the past decade, observatories have recorded dozens of distant collisions of black holes and neutron stars by catching the way those events stretch and squeeze reality as the waves wash through Earth. Add a second instrument class that listens using millisecond pulsars as timing beacons, and you get sensitivity to waves so slow they take years to roll by. Put these listens together and a picture begins to form. Space is not flat emptiness. It has texture, valleys, ridges, long, shallow troughs that hint at natural corridors. Now take the pilot's view. Spacecraft already surf gravitational fields. We use planetary flybys to steal or shed speed without burning fuel. Mathematicians map low-energy pathways called manifolds that thread the three-body problem, letting probes drift from one gravitational neighborhood to another, like leaves in a current. Scale the idea up to galactic size. The Milky Way's mass is not smooth. It is lumpy and rotating. Spiral arms are overdense. Stellar streams thread the halo. If you launch along a groove where all those pulls add constructively, you can ride the curve with thrift instead of brute force. Could anyone literally surf a passing gravitational wave? Not with physics, we know. The waves we detect are unimaginably faint by the time they reach us. They are glorious for astronomy and useless for propulsion. But the steady shape of the galaxy's gravitational field is another story. It provides slow, patient guidance. Think trade winds rather than tsunamis. A craft designed to exploit long-lived gradients could follow pre-computed contours that keep delta-v cost low and error bars forgiving. The path would not look magical. It would look like a hyperbola that just happens to thread the same favoured avenues again and again. Here is where our mystery loops back in. The Archer sits along the line to the galactic centre where the mass budget swells. That does not mean anything supernatural. It means the gravitational map has more structure to work with along that sightline. If you were planning an intercept with our orbit using little more than careful launch and long patience, you would prefer such a hallway. Relative velocities line up. Timing windows broaden. The intercept geometry is kind. A courier riding that corridor would present exactly as a natural drifter to first glance. Can we test any of this without starships of our own? Yes, by building a chart. First, we keep counting interstellar arrivals and correct ruthlessly for where our telescopes actually looked. If a corridor exists, arrival bearings should cluster into a gentle cone that points along well-understood gradients rather than smearing evenly. Second, we look for speed bands. Natural ejecta come with a wide spread of velocities. Routes engineered for thrift prefer sweet spots where gravity lends a hand. Third, we compare with independent maps, spiral arm tangents. Stellar streams identified by precise star catalogues. If visitor paths rhyme with those structures more than chance allows, the corridor idea earns a stripe. There is a practical payoff, even if no one is guiding anything. Natural debris will also prefer the easy lanes, because the same geometry shepherds everything. Knowing the lanes lets us predict where to point the next generation of survey telescopes to catch fast movers earlier and longer. That means better spectra, cleaner light curves, and tighter orbits. It also means we can design intercept concepts that do not rely on reaction engines alone. You launch into the flow rather than into a headwind. Skeptics will remind us that gravitational maps are not highways with painted lines. They are gentle preferences smeared by noise. True. That is why the hunt must be statistical, not anecdotal. No single object will prove a corridor, a population will. Think of how sailors learned the trade winds. One voyage could be luck, 10 in a row become a chart. The dream version of this chapter arrives later. Pulsar timing arrays mature and give us a cleaner view of the slow heave of the galactic background. Surveys tally dozens of interstellar visitors with honest exposure models. The plots begin to show a faint tilt. Slightly more traffic from bearings that align with the inner mass gradient. Slightly narrower speed distributions along those bearings. The signal is small, but it repeats across independent teams. Not cinema, just cartography. Suppose the chart appears and the lanes are real. Then, our list of next moves writes itself. We bias our watches along the lanes. We build small, fast interceptors that can be fired on short notice when a new object enters a mapped corridor. We practice flybys that skim the coma within safe margins to taste chemistry directly. We time low-power hails to the moments when geometry gives us line of sight down the lane, because if someone is riding it, they may also be listening along it. Everything gets cheaper when you let the map do half the work, and if the counts refuse to show any preference, good. That answer tightens the leash on speculation and pushes us back toward deeper natural histories. Either way, the exercise leaves us stronger. We will have the best gravitational weather report our species has ever owned, and the discipline to use it. The universe rarely gives us signposts with neon. Most of the time it gives us faint grooves worn by millions of years of motion. Learn to see the grooves, and you do not need miracles. You need patience, good instruments, and an appetite for maps that get a little clearer every season. That is how explorers work when the ocean is the size of a galaxy. Picture a museum with no roof and no curator. Artifacts drift for ages, their labels blown away. That is one way to see interstellar space if technological life is common but short-lived on cosmic scales. Civilizations rise, build, launch, and vanish. Their hardware keeps going because hardware does not miss sunlight or vote for budgets. It just follows instructions until power fades. If 3i Atlas is ancient, it could be a relic from a culture that burned out before mammals had a plan. This is the orphaned probe idea. It does not ask for miracles, it asks for time. Launch a machine from a system that orbited the galaxy 10 loops ago. Let stellar tides and close shaves with other suns stir the path until the breadcrumb trail smears. The makers go quiet. The probe wanders on. When it finally brushes our neighborhood, we see a one-time visitor with no clean return address and a chemistry that reflects a birthplace colder than our own. Tragic, testable, weirdly plausible. We already make such ghosts. Voyager 1 and Voyager 2 will drift for millions of years after our power fades. The golden records will survive as scratched metal long after their music is dust. If any young species meets them in a far future, they will not meet us. They will meet our echo. They will hold a scratched circle and guess at the hands that cut it. Now flip the telescope. If Atlas is a relic, we are the children puzzling over a message made by grandparents who never met us. How do you tell a relic from a rock? You look for fingerprints that geology does not leave. Unusual isotopes trapped in dust grains, alloys that do not match stellar abundances, microstructure that looks machined rather than frozen. Those are hard to spot at a distance. They may hide in the coma dust where gas drags out tiny fragments of the shell. That suggests a mission you can sketch today. Small flyby probes with aerogel collectors to catch dust gently. Onboard mass spectrometers tuned for weird isotopes, not organics. Return a few milligrams of truth instead of pi. 1,000 guesses. Spin and heat can whisper too. Ancient machines that still regulate temperature may show stubborn thermal behavior that refuses to track day and night like a simple rock. A faint, repeatable flicker in the light curve that does not match expected shapes could hint at buried symmetry. None of this is a smoking gun alone. Together, over multiple nights and teams, the pattern could lean away from natural and toward made. There is a melancholy branch of this idea that deserves daylight. Call it galactic archaeology. You assume minds are not rare, but long-term stability is. Most fail before they can share a sky with neighbors. The galaxy becomes a graveyard of machines. Some still work on autopilot. Some are skins of ice wrapped around cores of silence. We learn by cataloging their debris the way we learned human prehistory by reading pottery shards and tool marks. It is a sober narrative, but it is not despair. Archaeology is a way of honoring strangers by understanding them. The thick disk of the Milky Way holds stars older than imagination, metal poor, ancient. If a civilization arose there early and launched widely, its artifacts would be older than our continents. Their surfaces would be reworked by cosmic rays into glassy skins. Their volatiles would be a palimpsest of original ices, plus whatever they picked up from clouds and flybys. That complexity is not a bug. It is the context you expect for a thing that has crossed half a galaxy. Skeptics will say that every one of these tells has a natural twin. Isotopes vary in comets. Dust can look oddly uniform. Thermal curves surprise. True. That is why the symmetry idea lives or dies by accumulation across a population. One object that feels old and orphaned is a story. 10 with similar oddities form a field. The goal is not to crown Atlas a monument. The goal is to build enough cases that a pattern emerges independent of our favorite example. There is also a responsibility that comes with this. Lens. If you think you might be reading someone's ruins, you do not break them to prove your point. You sample gently. You publish carefully. You avoid contamination. You share methods so others can check without destroying what you barely understand. That is not superstition. That is craft learned by archaeologists on Earth and lifted into a bigger sky. What would progress look like in the next few years? A network of survey telescopes that flags interstellar candidates earlier. A standing plan for a quick launch flyby with dust capture and rapid analysis. A shared archive where spectra, light curves, and models live in public. The first time a sample comes back with an isotope ratio that makes nuclear chemists swear and smile in the same breath, this chapter will tilt from mood to measurement. Until then, hold two truths at once. Nature can make wanderers that remember nothing because time erases. Civilizations can make wanderers that remember nothing because their senders are gone. Both readings produce quiet visitors that pass once and leave us arguing on rooftops. If Atlas is only ancient ice, it is still a letter from a distant freezer. If it is a relic, it is a letter from a vanished hand. Either way, read it well. The cemetery is only a tragedy if we refuse to learn from it. Turn the question into hardware. If another once-only visitor shows up tomorrow, how do we meet it with more than wishful thinking? We build a standing playbook that lives on shelves now, not after the press conference. The plan fits on one page and unrolls into a stack of tools any spacefaring culture can afford if it stops improvising. Step 1 is early warning. We widen the net with survey telescopes that scan fast movers every clear night and publish candidates in minutes, not days. We reward recovery hunts in archival images that tighten orbits within hours. A sharper path buys us launch time. Every day counts. The clock is not a metaphor. It is orbital mechanics. Step 2 is a ready launcher, not a bespoke flagship, a kit. Think of it as a comet courier in a closet, a small spacecraft with 3 chores and no drama. First, a dust catcher made of aerogel tiles to snag grains gently as they stream off the coma. Second, a compact lab with a mass spectrometer tuned for isotopes, a microgas chromatograph for organics, and a tiny electron microscope for textures. Third, a radio and laser package for time-stamped hails and passive listening. The bus is simple: sunlight for power, cold gas for trims, navigation that trusts gravity and good math. Step 3 is trajectory discipline. We launch into the flow, not into a headwind. A solid orbit solution lets us aim for a grazing flyby that kisses the outer coma where dust is rich and risk is tolerable. We choreograph the path so the dust shield faces into the stream and the instruments wake in sequence. We do not chase the nucleus. We taste the fog, because that is where the fingerprints live. If the object is natural, the grains tell its birthplace. If it is not, the grains are the safest place for secrets to leak. Instrumentation on Earth does the heavy lifting too. While the courier races, a ring of telescopes coordinate spectroscopy across infrared, visible, and radio. Polarimeters watch scattered light to measure dust shapes and uniformity. Radar tracks distance when geometry allows, locking the orbit tighter. All windows and settings are pre-announced so amateurs can join with calibrated gear and fill gaps. The sky is big. The more eyes, the better. Communication is an experiment, not a stunt. The hail protocol is humble by design. Narrow beams, low power, a handful of agreed times and frequencies. The content is simple timing markers with checksums that any receiver can verify without guessing our language. We publish the plan months ahead, then we watch together for repeatable nudges that fit the schedule and survive boring explanations. A micro dip in a coma line, a millimeter per second, tweak to an already measured drift. Boring. Yes, that is the point. Drama is easy to fake. Reproducible small effects are not. Ethics and hygiene are part of the blueprint. No kinetic impacts. No contamination, no classified data lanes. Every command and every time tag lives in public before it happens. Every detection threshold lives in public before it is claimed. Negative results get archived with the same pride as maybes. Planetary protection extends to interstellar visitors because good guests do not shed problems in someone else's house. Cost control is attitude. We build once, fly often. The courier is modular. When the next object pops up, we bolt the same kit to whatever commercial ride can get us out the door fastest. We practice on friendly targets in our own comet family to burn down risk. We publish the failures so the next team does not repeat them. We do not wait for the perfect mission that dies in a committee. We ship a good one and learn. There is room for ambition without vanity. A microsail stage can give the courier a gentle kick for late-course trims without heavy propellant. A tiny formation of daughtercraft can spread the dust catch across several paths to hedge against a miss. A relay of ground stations can keep the downlink open through the whole pass, so no data dies in a buffer when it matters most. None of this breaks the bank. All of it turns luck into margin. What does success look like? A few milligrams of dust sealed in a clean vault with isotope ratios that make chemists sit up. A stack of spectra that agree across continents about a volatile mix. A light curve whose fine structure repeats with a period that matches a tidy shape or a stubborn thermal habit. A hail response that passes 3 independent checks without heroics. Not fireworks. Footnotes that pile into a conclusion. And if the visitor is only old ice, we still win. We will have built a machine that reads the birth certificates of other solar systems. We will have practiced an open protocol for global experiments that do not depend on press cycles. We will be faster, quieter, and better at saying we do not know yet in public. The intercept blueprint is not a bet on aliens. It is a bet on discipline. When the next object lights up the feed, discipline is what keeps wonder from outrunning truth. Picture the moment when the numbers stop wobbling. A microdip repeats after 3 pre-announced hails. A coma line twitches by the same tiny amount, on schedule, across 3 continents. The radar drift shows the same feather-light nudge inside the error bars we froze months ago. No fireworks, no music swell, just the cold thrill of a pattern that survives every boring check. That is what a yes looks like in the real world. Small, repeatable, hard to deny, easy to share. The first rule is slow, is smooth, and smooth is fast. We do not sprint to microphones. We sprint to replication. Another team runs the same code on the same public data and gets the same answer. A third team uses a different pipeline and still lands in the same box. Only then do we say the word out loud. Until then, we say what is true. We saw a repeatable effect at the right time and place. We are testing it in daylight. We will have more soon. The second rule is tell the story with receipts. Every timestamp and every threshold lives where anyone can read it. Every plot ships with the raw points underneath. When reporters ask how sure are you, we answer with numbers and with the ways we might still be wrong. When skeptics offer alternative causes, we test them in public. A real yes does not need a velvet rope. It needs a wide aisle and bright lights. What counts as enough? Not a single indicator. A braid of them. Timing modulation that keys to our hails or to a published metronome. A chemical line that flips between 2 states no heating model can reproduce. A light curve flicker with a period that matches a tidy spin and a tidy geometry across changing phase. Angles. Each thread alone is interesting. Twisted together, across independent groups, they become the rope you can hang a claim on. Then comes the human layer. Curiosity wants to run ahead of caution. Fear wants to slam the door. We keep both on a leash. We convene open calls with engineers, statisticians, and psychologists who think about risk without drama. We invite the dumb questions early because dumb questions are often the best shields against self-deception. We remind ourselves that a yes to a whisper is not a yes to a landing. It is a yes to coordination. It is the beginning of a slow conversation, not an ultimatum. Diplomacy has a quiet role even here. No one speaks for Earth alone, so we speak in unison about method, not meaning. The message is simple. We observed a small, repeatable effect that matches a published protocol. We invite every capable observatory to try to reproduce it. We will not assign motives. We will not speculate beyond the measurements. We will not change the plan without consensus in daylight. That tone keeps the room calm and the science clean. You might ask what we do about bad actors. The answer is daylight again. When the entire method and schedule are public, there is no private channel to hijack. When every team can check the sky for themselves, conspiracy wilts. When thresholds are frozen before the test, no one can move the goalposts after the whistle. The best defense is the boredom of good process. Now the practical next step. We aim for continuity. The effect repeats on a timetable. We keep watching on that timetable for as long as the geometry allows. We layer in more bands and more instruments. We try a second handshake with a slight variation that we also pre-announced months ago. We do not chase novelty. We build a scaffold of predictable tests and let the other side decide how much of it to climb. What about meaning? That is the part we postpone on purpose. A measurable nudge is not a manifesto. It is a wave through, a window. The message we send back is not a speech. It is care. We keep our house in order. We keep our promises. We show that we can carry a delicate truth without dropping it in a political storm. That is how trust begins between strangers who share nothing but physics and patience. There will be art and philosophy and late-night tears. That is human. There will be people who feel small and others who feel seen. That is human too. Our job on a channel like this is to hold the line between wonder and wishful thinking. To keep the cameras pointed, the code open, and the voices steady, while everyone else processes what a quiet yes means. We can do that. We have done harder things than telling the truth carefully. So imagine the graph again. 3 tiny dips, right where they should be, across instruments that do not know each other. Imagine the first press conference that says as little as possible and exactly enough. Imagine hundreds of telescopes turning to watch the same quiet window as the sky keeps its own counsel. That is how a civilization walks through a door it did not build, not with a roar, with a plan. Stand in a dark room with a single window. Outside is a city you can barely see, full of lights you did not wire and roads you did not pave. You press your forehead to the glass and wait for a pattern to emerge. That is where we are tonight. A narrowband knock from the Archer decades ago. A growing radio bubble that tells the neighborhood we woke up. A one-time visitor on a hyperbola that refuses to name a single home star. 3 beats that feel like coincidence to the cautious and choreography to the bold. We have walked both roads without flinching. The natural road says ancient and scrambled. Time plus tiny forces erase the return address. Chemistry leans cold. Coma vents focus through pits and cliffs. The engineered road says patient and disguised, a route chosen to look ordinary. A shell tailored for quiet, a plan that rewards people who measure more than they shout. Neither path asked for fantasy physics, both asked for discipline. We mapped the tools that turn wonder into work, orbital rewinds with honest uncertainty clouds. Spectra stitched across night, so chemistry is a story, not a snapshot. Light curves watched for stubborn rhythms, polarization to weigh dust, radar to lock distance. Timed hails that are humble, public, and reproducible. A courier on standby that can taste coma dust and bring home milligrams that talk louder than 1,000 takes. We let skepticism drive. Survey bias is real. Instruments have personalities. One-time events trick hungry eyes, so we wrote receipts into the plan. Pre-register thresholds, publish null results, share code. Invite the loudest doubter to help write the test. Insist that any yes be small, repeatable, and boring in the best way. Demand that a stranger's telescope can see what ours saw without knowing our hopes. We let imagination earn its seat. Gravitational corridors are not fantasy when they are just thrift written in the shape of the galaxy. Quiet networks are not mysticism when they are simply good security and good engineering. Galactic archaeology is not despair when it is the honest outcome of deep time. These ideas do not replace measurement. They tell us where to point it. We asked what a careful yes would look like. Not a landing, not a speech. A millimeter per second nudge on a schedule everyone knew months in advance. A micro flicker in a coma line that keys to a shared metronome. A handful of dust grains with isotopes that make chemists whisper in lab coats at 3 a.m. Small, public, cross-checked. The kind of yes that builds trust because it survived boredom. Now the mirror. It does not ask whether we are alone. It asks whether we are ready. Ready to keep attention alive when news cycles die. Ready to coordinate without drama. Ready to tell the truth carefully when the truth is strange and small. A patient watcher would care about. That more than it cares about how loud our transmitters are. Method is a language. Humility is a credential. There is work we can start before the next visitor appears. Turn the intercept blueprint into hardware. Fly the courier past our own comets to practice the dance. Build a living calendar of outbound hails and publish it so the whole planet can watch the same windows. Train the machines to find patterns, but chain them to transparency so they cannot sell us ghosts. Fund the dull parts. Archiving, timekeeping, version control. That is how grown-ups do magic. There is room for awe even inside all this caution. The universe already gave us gifts. A tone at the hydrogen line that still glows in a museum case of the mind. A robot with a record that says we chose music when we could have chosen noise. A traveller that asked better questions than we were ready to answer, and still made us better at asking. None of these require aliens to matter. All of them require curiosity with a spine. So here is the final promise. We will keep the camera pointed at the Archer without turning myth into method. We will hold ancient and engineered in the same hand, and let evidence do the tilting. We will chase the next fast mover with instruments warmed up and ethics locked in. We will publish when nothing happens, and speak softly when something does. We will treat small facts as sacred. Someday a graph may nudge on cue. Someday a grain of dust may tell a story no comet has ever told. Someday the choreography will stop being a metaphor and start being a plan we recognize from the inside. When that happens, the mirror will lift and we will see what the universe has been asking all along. Not whether we can hear, whether we can listen.